Swayam Prabha. Digital India. Educated India.
And good morning to all of you. So I was told that this is on the deep tech innovations, and to some extent, my journey relates to that. Last 10 years has been accidental in my life. I came to Chennai because somebody told me that if I do BTech in nanoscience and nanotech, I would be joining the next industrial revolution because before 2009 or when I was starting my BTech, it was IT. I came to Chennai for that, and to find out that a 19-year-old BTech graduate cannot be doing R&D for Seagate or any Saint Gobain or any company which because R&D is very serious stuff. But that there was one thing that this particular program or reason for me coming to Chennai was that I was told that by learning nanomaterials or nanoscience, you can exactly tell why this pen is green and can you make it blue. So you have the power to identify the reason and control it, right? And so I had a vision that maybe one day I will have a stick in my mouth and I will swim in ocean and that stick will purify the water. So like there's a lot of wild thoughts, but then that one control that you can have basic level control of materials around you. You can understand it. I wanted to make my headmasters disappear using computers because I was his target. And fortunately that I was his target and I was doing good in the school. But then as a kid you don't understand, right? You want to make him disappear. But then I learned computers can make things which are impossible. Computers, I was seeing newspapers, food coming out of computer. Why not make professor disappear using computer? So that was the one which was not really factual inspiration, but an inspiration which led me to doing nanomaterials and nanoscience. And once I came here, I was just going here and there, like going IISCRs or IIS to experiment with things because internships would allow you to do just the instruments which are 4 crore of facility. And otherwise, I wouldn't get chance to do that. And running around, I found out instead of running around here and there, it's best for me to come to this campus here because my BTech was in SRM. And then at the second year of my BTech, I wrote a mail here and I wanted to do internship. I knew nothing about, and I got a theoretical physics internship opportunity. I was just wanted to do it. It was like colliding protons with hydrogen atom and then seeing the trajectory of resulting molecules or resulting particles that will come out. So basically, you're trying to understand the particle trajectory. I know a lot of maths, and eventually things did not work out with me. So I wrote another email, or I met another professor, which is also a co-founder in my company. I went to him, and I'm just narrating the stories because that's how I suppose this class can be a story. I went to him and I told him I had a list of 10 people who were relevant to my previous internship backgrounds. And I went to the first person who happened to be, his name is Professor T. Pradeep. Rajan sir knows him. And he just finished a group meeting. Every Saturday there is a group meeting. And I went at the right time and he told me, have a tea. I started having tea. And why are you here? This is the reason I want to do internship. Why? I have 50 people here. What makes you different? And he started interviewing during that tea that he offered me. And it went in such a way that I left the tea and I had to tell him, sir, give me one more chance. I would like to attempt the second time. And I left the lab. Right. I went back again to him and I told him ABCDs can be done. And yes, you have people, but I am no less than the people that you have. And he gave me a opportunity because he's a very logic oriented person, right? So if you convince, and then there's a human tendency that if you can convince the person, he will give you the opportunity. So I got the opportunity, and then this is what my journey on water had started with him. My first task was to make a bottle that can purify water and specifically designed for natural calamities, which means that instead of throwing Bisleri bottles of water can bottles post flood, you throw these bottles, and then person can purify water into them and then get drinking water out of it. Now that was a product, like you know, because his understanding was that I'm a technology person. I was going there for research. So I'm being given a task to build a product. Now that product on the back end involves a lot of things which I really did not know. I was like, kuch karenge, right? Now that involves key when you first look at the flooded water, it can be anything in there. You can have biological contaminants, you can have chemical contaminants. A biological contaminant can be again anything. It can be anything, because the flood water is wash off of everything that we have on the street, on the sewage line of the homes. So you have to have a system that can get rid of bacteria, all the bacterial biological contaminants, chemical contaminants. So that involved, you need to know about the membranes, you need to know about the materials, and then you need to know about the design, SolidWorks, A, B, C, D, and then you have to have a device which can be used in natural calamities. You cannot be sitting there and asking, give me power, I will give you pure water. So we made something that got us some recognition, and but by then we were doing a lot of things. So this is a opening picture I'm sharing here. So this is current where we are, and this picture explains what we are rightly doing, and I will come back to this. That time, this is a bigger level what the problems we are having. So we have all around the water, but we take the urban sector or the rural sector. The quality of water or availability of water is really not there. If I go home, so you see this picture. This is me in my home. I didn't want to show the pity pictures कि मैं गांव से आया था, कुछ नहीं था मेरे पास, मैं ऐसी जगह से आया हूँ जहाँ पे पानी नहीं है. But yes, I am from a place where you value water really a lot, because you when you're filling a pot, you make sure that there's no drop of water going outside the 5-inch mouth. This is Sir Hanumangarh in Rajasthan. Yes. So, and that's me, all in pant shirt, along with all the my, I would say my village colleagues. So, and from there, this was the bottle that we made, and we got recognitions at Prime Minister's Rashtrapati Bhavan. So this is a bottle that you see. On the back end, you have a pump which can be hand operated, and then that will create some pressure, and this will get into the water will get into something like which of this quality will go through a ultra filtration membrane, because then you have the pressure on the backside, and then you have this type of material available also, and then you can select the material whichever you want. If the flood is in Ganga belt where you have arsenic, or flood is in Rajasthan, or flood is in Chennai, so understanding what kind of chemical contaminants you can have, you have opportunity to change the materials, and then eventually from this faucet water will come out and you can drink this. So this was first product that we had, and after that we fortunately all the work that I was doing completely involved making products and doing the end line activity for the PhDs who were there in the lab. Let's say if somebody made a material, I would be tasked to do its pilot study. I would be tasked to do its lifetime study and really evaluate, does it make sense to put it in the field. It could be the case that we have made a material which will remove the arsenic, but can it remove arsenic when the pump is running, because then you have a certain flow rate. I can pour water with arsenic, pour my material and say ki arsenic, arsenic has disappeared. But it wouldn't make much sense, but it will make real sense if it is able to remove during that flow rate when I'm taking water at my home or at a community level filter. Understanding this problem, and you have, there's a lot of water related problems around us, and needs different level of handling it. My second task that was that we will be making a fluoride pilot plant which will remove the fluoride. So this was further designed by Rajasthan. We made this for Rajasthan government. Then this was another product that we made, which involved making. So you in like you saw that there's a pot which eventually the person will carry on the head, and as a muscular person, I will carry like this, right? Now, what if you can put these things, whole things, in a roller, and there have been products of such kinds, and make it more usable. Like you do not want it to be completely 20 kilogram volumetric space, but can you make it foldable also? So we made this is a paper bag, or a plastic bag, which goes into these products which are again foldable. Like you can open it up in its basic building blocks, and then you can fold it up, or you can use it for storing other items also. So idea was that once you fill in the water, let's say I'm going to a common tap or a common well or a common pond from where we're fetching water. By the time I come back to home, is that water potable? Can you do that? So inspiration from the previous bottle, that you have a mechanism to create pressure, you have mechanism to remove biological contaminant and chemical contaminant. We inserted the same thing into this drum, that you fill water 20 liter, do some pumping. By the time you come back home, there is a materials that will again take care of the contaminants, and when you come home, you will get drinking water. Last task, or this is my material master's thesis task, that the materials that we were making now, that keeps getting on improving, make it better, efficient. Yeah, so this was the how do you make a material which is made in 2-gram quantities in lab to 2 kilogram quantities in lab, and then you can do a field trial of it again. So till now the task is, whatever 2-gram or 10-gram has been made, you check its capacity. Now you have to make it in bulk and then check its capacity to see, can you really take it to the field. So this was a, like you have the base chemical, then you make kilograms. So what you're seeing here is a 1 or 2 rupee coin, and then you can see, this gives you some idea that there is really a bulk quantity of 2 kilograms, and then this goes into a filter which was already there by a company called Hydromaterial. So you have to now do 2000x to make it to the field, and if you can do that 2000x job, then yes, you mean, like there is another company which can start operating. So this was a pilot plant that was designed. Now so you have different jars where you can do, at a time you can involve 24 chemicals, and perform 5 different reactions, or 13 different reactions, because even here also you have a opportunity to do a reaction first. So subsequently you can do 12 different reactions using 24 different chemicals, and then you can actually make whatever the chemical that you're doing in lab, you can do a synthesis at bulk scale. Now that chemical can be anything. For my case, it was a material for removing arsenic, but then it can be anything. And this facility, I think, we do not have much such facility in academic environment till last few years. But this gives also an opportunity that if you could do a bulk scale production in few kilograms, you immediately have indication that yes, there is a serious scope of doing a venture on this. because the tech is only saves when let's say Tata Chemicals starts making chemical. Uh, that edge on the science part is only what you can be depending on relying on, and to rely on that you need this evidence at the lab scale, or before you set up a facility which can make 100 kilograms or 1 ton of material every day. So this is a facility. It's there in IIT Madras now, in HSB department. And then, so along with all the things that we were doing, there was one project that was can you capture water? Because then our entire activity was on materials and surfaces. So can you make surface similar to beetle? Now there are a lot of beetle species, animal species, and plant species in desert, which captures water from air. Because in desert nobody goes and gives water to them, but there are species in desert. Uh, like if you look at Sahara Desert, like it's a very vast. Unless water comes from the clouds, you really do not have any uh, water droplets there, but there is life in that desert, animal life and plant life. So idea was that can you replicate the mechanism that these lives are using to get water in desert? As we tried different practices, now this is some of them I am showing here, that you have a pattern of hydrophobic surface and hydrophilic surface. So hydrophilic will capture the water, and once the droplet gets bigger, hydrophobic will push it off. So this is a practice used by a beetle called Stenocarapita, which has wings, and these wings are having these wax materials. There is hydrophilic, there is hydrophobic. And then further, how do you make it more efficient? Can geometry help you to capture water, or can geometry help you to push off that droplet of water so that that surface is available for you, to again capture the water? Uh, and then other practice that we were trying to do is trying to understand the cactus plant. Now cactus plant makes water in desert, nobody waters it again, and it does that because you have these conical surfaces there. Now in the morning, the dew or the water content in the air is similar across your home, but the dewdrop will first come and get formed on the plant leaf, and if you have cactus, then it will first come even on that. All right, and then you have banana leaves, so banana leaf also captures water. So these plants have morphology designed in such a way that they capture water. Nowadays, understanding that nowadays people are doing fog hydroponics. You put fog, and from that fog the plants will capture their own water on the leaves, and the water will start slowly come to the root. Fog hydroponics or fogonoponics, something like that. Uh, so we were not very successful in replicating the Stenocarapita because the surface, the materials that we were using will wash off in some time, and then you require more R&D on that. But we were able to replicate the cactus plant surface. And so this is a paper from us where you see the smaller droplets forming. So first nucleation. So I'm trying to explain the condensation, or the core of all the atmospheric water generators which are there in the market. And then these droplets will come form a bigger droplet. And once the droplet is of size, then the gravity can show its effect on it. The droplets will fall, and then you again the same circle. So generation, nucleation, coalescence, and then transport of that drop. So now that all three steps are happening here, and we were using these surface in a refrigeration circle, which which is allowing us to again capture water, because for any surface to capture water, we keep its temperature below dew point. So we were keeping surface temperature below dew point, but the metals will have surface similar to a cactus plant. This is a video which I have added here. So this shows at micro level how the like, since at micro level focus it cannot be done very well because you have the tones. So the focus here versus the focus here are slightly different. So please watch it with that eye. So if you see here, you see the small droplets and suddenly becoming bigger and then disappearing, and then that cycle continues. So this is what actually cactus plant does. We are doing it at higher density on a metal surface. So this was, in fact, this is core of why we have the current company called Vayujal, where uh, So this is another picture. Ki how we are doing a 10-meter long roll in the lab uh, to make to do a screen printing on the lab manually and make a roll from there to here, and then use that roll to make heat exchanger like the coils that you have air conditioners. So these are the basic seats that goes in making the air conditioner heat exchangers. So this is again the large scale or the pilot testing of the materials or the surface engineering that you're doing. Now, this resulted into a good video, a good inspiration that yes, you can capture water. And subsequently, we got and we did a pilot trials in the machines, and then the you try to start looking at where can you fit this, because when we start companies, the technologist, we do not come with the problem, we come with the product first, and then we fit that product to a problem, uh, which is fine, I suppose, as long as we find a problem to fix this upon. So the immediate problem or you know, that we had is that there's a two problem that we're addressing now, that if we continue with the human activities that we are doing, by 2050 or probably when we are old, we will not have Ganga water. I hope that I'm wrong, but there's most likely that we will not have. And so what we will have as form of raw water is only sewage, canals of sewage, groundwater, which is something similar to sewage, which is highly contaminated, or the water form that is available in our humidity, in our climate. So those will be the two sources of water at that time. So what we are now doing is that now we had a discovery that yes, you can make surface to capture water, and eventually the result is that you can make a liter of water by spending lesser energy that what other guy otherwise would do by doing condensation on a flat metallic surface. And now we trying to see can you make these atmospheric water generators more efficient, so that even today this bias exists that people with better socioeconomic economic status has access to better quality of water. Uh, the other side of it does not. And as long as the affordability is not in the context, that bias will stay. I mean, I do not have clear target right now, but yes, I would like to see that in my life, that you have access to water, and unfortunately from air or from sewage using tech, that it is more affordable to both the segment, whether you are at the base of pyramid or on the top earning like Ambani's. So that's the bigger vision that I personally have and we at Vayujal have. But other immediate problem is this that we are seeing that today we almost drink water. This bottle is fortunately there. I brought one more bottle with me. Uh, so this is, or this is a smaller packaging of bottle that we have, water we have. Otherwise, our water comes in a 20-liter jar. Now, all the water that we have here is, almost 99% of it, could be slightly here and there, but it's RO treated. And that RO is also getting water via a tanker or a municipality pipeline. And again, from wherever that is getting generated, it's either the groundwater or uh, groundwater or the surface water. Now, if I go back here to get a liter of water, or in this my plastic bottle, I have to feed at least 3 or 4 liters to the RO plant. And to feed 3 or 4 liters to RO plant, for example, if I'm running on municipality water, the municipality will have to pump at least 6 or 7 liters of water, because the current piping systems that we have, the pipe infrastructure, adds somewhere between 40 to 60% of water that is lost. It's a non-revenue water. We leak. That there's a wastage of that water. So effectively, and then if it's a tanker water, then the dependency goes even higher. We cannot be running domes relying on tanker water. Uh, Maybe we are running right now. I'm not sure of exact exact facilities management. But in a longer run, you cannot really rely on tankers. If you want to run a HCL, or if you want to run entire IIT, uh, that's absolutely not a good idea. Nonetheless, if you were to do that, if I were to get 1 liter of water here, I will have to start with 6 or 7 liters there. And on the process, I will be generating 3 liters of reject water, which again has to be handled. So there's a water footprint which I have for me to drink 1 liter from this bottle. There's a water footprint of 7 liters. There's a transport involved. There's a infrastructure involved. There is a water wastage that I'm generating. There's a plastic wastage that I'm generating. And then the packaging that we are doing has microplastics, and due to the lack of analysis till a year, we did not know that there's nanoplastics also. And in fact, to my surprise, and when I will say the numbers to you, maybe to your surprise also. And then again, it's research, and research is never, one number. It keeps evolving. What is true today may not be true tomorrow for Jaipur, because again, regional wise things also changes. But the number that we have is that in a 1 liter of water packaged in plastic, you have around 2.4 lakhs of micro nanoplastics. And this entire or majority of sits in our guts, spleens, and we do not eject it, and we die with it. And that doesn't help us, it actually accelerate our aging. So we have that contaminant also, and the process of RO has its own disadvantage or advantage. Even if you're doing 100% RO, you will be spending very high on energy. If you do nano filtration, let's say, then today you have ABCD. I will name the ABCD. You have steroids in groundwater. You have PFAS, polyfluoride, or PFAS, which is very fancy name now in water industry. So you have chemicals which are very not really unknown. You have hormonal contents in your groundwater. You have pesticides in your rivers, or my rivers, or my water. Uh, so there is no assurance on that unless you are doing a 100% intense RO, which I suppose a brand such as Bisleri will do, or when we talk about a 200 rupees water bottle or 500 rupees water bottle, those folks will do. But then the economics will go very, which is definitely for Virat Kohli, not for me. So with that, we are trying to solve the, can you remove this whole chain that is there, the, the plastic waste involvement, or the transport, or the filtration system. And can you make water at point of use? So this is a picture of our planet that I have incorporated here. This shows that you have around 1.4 trillion liters of water in our atmosphere, and this is available in two formats. One is visible, which when this water content goes to a colder climate, it forms cloud. But when it evaporates from ocean, we do not really see that water content. It is transparent. And the moment it reaches Yelagiri, it will form a cloud and it will pour on Yelagiri. But when it reaches Jaisalmer, it will just go like this. It doesn't care about Jaisalmer because there's no colder climate there. So you have this 1.4 trillion liters of water. Every day there is a million liter of water pouring on the ground. Every day there is a million liter which is evaporating, and it is traveling in a direction where you have less vapor pressure. So wherever you have high vapor pressure will automatically travel to. So when we say Jaisalmer doesn't have water, actually it will be wrong. The air of Jaisalmer has a lot of water, uh, and the ground, I suppose, ground also has. But the air is always, has this water content, no matter how much of water I extract out of it. And now that gives us an opportunity to keep on, making, considering that this could be my another uh, limitless source of water. And I hope this, this doesn't become another story that after 200 years we stop saying this is limitless, because as human, whatever we understand as limitless, after a decade it becomes, it has that it comes with limits. So for today's understanding, we'll take that there's no limit. We can extract whatever amount of water that I want to make. Now there are proposals of making atmospheric water generator of size of stadium and then giving water to whole Cape Town. This is an environmental study which may need, needs to be done. But then the things are, people are very serious about taking this as renewable water source. And there these global air currents are there, which shows the uh, you have water traveling in a certain pattern across the planet, and wherever I am, I will always get humidity, because just for a fun fact, uh, I learned that the sand of Sahara goes to forest, Amazon forest, right? And the nutrients of Sahara is nurturing the Amazon. So if wind currents can carry sand, why not water? Looking into this, and we have used that surface modification technology, and we put in these atmospheric water generators where we cool down the surface temperature, uh, having surfaces similar to cactus plant, and then do airflow on that, and that allows us to capture water at different scale. So today we are doing at smallest of around 40 liters to maximum of around 3000 liters per day. And now you're doing at point of use itself. So if I have to consume water at this class, then we can have a machine running at this class, so that the backend activity of this bottle reaching here is not required entirely, and the associated the disadvantage are entirely removed. So you have uh, like this is a process that happens in the machine, that you're taking fresh air, passing through air filter to make sure that you're getting quality. You generate the water. So this is the core component of the whole thing, and then you treat this water and give it for drinking purpose. And now you have healthy drinking water at point of use. You do not have to rely on municipality water coming at 6 a.m. or 2 p.m. or 6 p.m. Uh, so there is a independence from that supply system. There is a zero transport involved. There is zero microplastic. And now there's a trade-off that comes with these machines, so that you're giving power to these machines and then making water. I'm like, are you really doing the justice? So the origin of Biogel has been oriented towards doing justice on that side. You do not take a lot of water to make, uh, you don't take a lot of power to make less water. So that efficiencies are taken care of. However, if you do this on, let's say, renewable energy for a solar plant, so I like, and then let's say you pack it in this glass bottle, and you put a limit that this bottle will not travel more than 50 kilometers. Now you see these bottles sometimes coming from like Himalaya brand, coming from Himalayas. So we are actually transporting glass. So this glass is around 300 or 350 gram. Then it has 300 gram of water. Right? So when I do a branding, my water is Himalayan water, not touching plastic, I'm effectively also telling that I have spent on doing a truck or transportation from Uttarakhand to Chennai, and there is a hidden carbon which is there, or there is a hidden environmental footprint, because in the end, the transaction is with the environment. We are just the medium. So if you do this, the first picture which I showed you, right? So if you do this, you are actually taking renewable energy to make renewable water. And if otherwise, I would have generated around 40 grams of carbon, but now I will not be generating that. I will be saving on that side. Like, so every liter that we drink from solar powered Vayujan helps us to have our footprint in terms of carbon negative. So then that helps on the corporates will get benefit in context of, let's say, ESG reporting, or getting better sustainability certifications, and then getting better rent or better listing. For example, if we have Ascendus here. So if Ascendus has a lead certificate for, let's say, silver, they will be charging you 35 rupees per square feet. But if they have lead platinum, they will be charging you 40 rupees per square feet, because then it gives you other advantage. So, and that has been also pushed for corporates to have a sustainable uh, operations, so that this also helps them. This is some pictures about Vayuzel, not very related, but one number which I wanted to show here, that so this is something, let's say this circle is all about this is core of Pfizer. If this number drops by, let's say, 0.22, we are at forefront of doing atmospheric water generators. Today we are globally competitive. Lack of data, I will not check it. This is I am the best in global, but globally competitive. But the moment this becomes 0.22 or 0.20, you become the best in the world. So this is a energy water ratio saying that I will take 0.24 kilowatt hour, 0.24 unit to make a liter of water. And that's the crux of any atmospheric water generator. How much energy do you take? And if this can be tomorrow made without energy, very good thing, because in the end, the beetles and animals of Sahara doesn't take power to make water, right? But yes, they make ml, not even 1 ml of water. They make point 0.1 ml or 0.05 ml of water for their survival. Beetle. Uh, so eventually, if any of you or I hope in the world somebody, preferably me, can make a surface which captures water because of the surface engineering it has, and also emits energy, let's say using IR radiations, or and cools down the surface, and that would be a fantastic product to have, and the numbers will be drastically, let's say, maybe 0.05 or 0, absolute 0 there. So this is what we are at Vidal trying to improve on this number, and so we have till date we have done around 149 projects across India, one in Europe, and we have given to some big names, Tata Realty, ITC, Chola. So now we have machines which are running on wind power, which are running on solar power, which are running on diesel generators, which are providing water to BSF in Kutch region, which are providing water to the security forces in Assam, uh, which are providing water to hospitals, hotels, schools, uh, and other areas. There is one very favorite video which I will show you here. So this is a video from Rajasthan. It's in the district called Sambar, which is Lake City of India, probably. Now, Rajasthan doesn't have ocean. Rajasthan only has lake. Uh, very obvious, I think. But the specific of this is that the groundwater there, it's so salty. It's even saltier than the ocean. That's how allows you to make water, to make salt. That even if you put an RO plant, the RO plant will not really function there. You will have to dismantle it after a year max. Uh, I'm not going to pity side of it. Usually we say ki somebody died, so we are doing it, right? But yeah, I mean, like I got to know about the fact after doing the installation. So there was so you in Samba you do not have big villages of 700 houses or 500 houses. You have hamlets of 10 houses, 20 houses like that, and there children's particularly three children's died because you are drinking salt water. So this was one solar operated atmospheric water generated in that village. On the back end of this is solar, and this is why accept the commercial angle that we all try to pursue. This is a social angle that gives us peace. That this is a raw video from. So you see the village people or my colleagues from another village coming to this machine and taking water, like coming and taking water from this machine, and then they're operating on their own. Nobody needs to tell them what to do, what not to do. Yes, there is a bit of hand holding required. So that's all. My key things that I take away from my journey. This is my last slide also. Is that you protect your IPs on time. Sometimes we procrastinate, and the document that we should have written long back, and by the time we write, we find that somebody else has written something, and it becomes difficult, or you actually don't get that IP. I assume that you all have some level of aspirations for doing a venture. Uh, Founders agreement is very important. We usually do ventures with friends, but eventually friendship doesn't help, and it has helped some people, but uh, it's best to have founders agreement because that saves a lot of time, miscommunication, misunderstandings, and otherwise you will lose on the opportunities that you would have attended to rather than attending founders issues. Have clear scope of responsibilities. I think that's very common, but I just wanted to emphasize again on that, uh, and then put it on paper also. Out of you know sometimes personal repo, or in village or in Hindi we say lihaz. I hope you will understand this word lihaz. अपना संचय दिल्ली से lihaz. Okay, we respect you, so I take your word as it is. There are people who honor their word, but better than let's put it on the paper that whatever the terms are. And eventually, for my personal understanding has been that the technology is the only savior for us. Otherwise, there is financial muscles which are there, can which can easily make another atmospheric water generator. But unless you have technology, some amount of IP protecting them, you can stay in the field only then. And take the tough decisions. Again, I have taken wrong decisions because when you have all the headaches coming into, and then you say, "Yeah, kar do. Let's do it." Okay, I will pay 4,000 rupees extra. But then gets into habit of 10 more people in your background who will start paying you 4,000 rupees extra, and down the line it actually becomes a bill of 4 lakh rupees a month. So very tough. So, but again, the decisions which are usually requires a lot of headache, that saves you a lot of headache in down the line. That's all from my side. I'm happy to take questions. Thank you again, everyone, for listening. Machine will be around 2.6 lakhs, plus there was a solar. So the entire project was like now running. So we take AMC also. So entire project is 14 lakh rupees, where we 14 lakh, 1 4, where we do the hand holding of entire equipment for 3 years. So this is a CSR project where even donor gets the assurance that yes, for 3 years we will be taking care of, and after that it will be handed over to the community entirely. I mean, there is a community handholding now, but AMCs and maintenance, everything stays with us for 3 years. One thing, I'm like, I founded two companies. The other products that you saw, I registered those under the name of called Aqua Easy, like making Aqua easily available. But then this was one problem that I realized that this is definitely requirement down the line. Yes, the requirement is not very much now, but it will become, unfortunately, fortunately, uh, a air conditioner or another domestic appliance for everybody, or another commercial appliance for every company. So that was the main reason to stay with this product. The product was there. We were not the first company to make atmospheric water generators, but we knew the problem of that key. When you make water from air, uh, our idea was to make better surface for harvesting water. But during the journey, you also learned that somebody is making atmospheric water generator, but he's spending 0.7 unit of electricity to make a liter of water. And then you have a surface which can get water efficiently. So that difference is what set us, gave us clarity that yes, you put it in a product, and maybe license the IP or take it, on your own. So that was a clear indication for us if there's a value in the material that you have made or the surface that you have engineered. And since there were atmospheric water generators, we didn't have to create entirely new customers. There was customers which were very less, but yes, people were selling this product. And then there was very much evidence that yes, down the line water is going to be a big problem. So you have smaller customer set right now, and the customer base will always grow, like for this product at least. So that ensured that we stay with this. We were participating in a global challenge which asked us to make water at a bigger level. So that set a target that we will be doing 2,000 liters per day, and the whatever we made were, yes, let's, instead of directly spending heavy capex on a bigger instrument, let's build smaller ones. So we built the first 100 liters, and then we built 500 liters, and then we built directly 2,000 liters, and then we break it down to 1,000, and then we had smaller prototypes for domestic work. The filters are like you have tried to procure it whatever is there in the market. So the filters that we use are same that right now we are using to filter the AC, the air ducts, air that is coming. So whatever the centralized air conditioning systems are using, we use the same air filter. So it's available. Like even if you have a machine here, this person can also do that. Filtration system, we have kept something very modular, so that for a machine in Delhi, we ask local RO person only to do that and get the job done. So that helps us also to do better service. And otherwise, we even like it's a push fit. Like you put battery, take it out, put new battery. So something similar. You push the cartridge, take out the old cartridge. Yes, I wanted to do the business. Right. Eventually, I did not think of becoming a professor. Uh, but then you have these rejections, and I was very much fine with them. But then the product that we were making, there was always a person who could sponsor it. Like the first pilot that we did required 20 lakh rupees, and we got funding from SAR Group, which makes liquor. The second bigger project that we wanted to do, we got funding for that. So the moment somebody else is giving you free grant, and particularly a private company, not a government agency, that's also sort of validates key. Yes, the other guy is putting money because he also sees potential in what you're building. But then it's your conviction also that you are actually building a next household, or another commodity for everybody. This is my vision. My belief is that this will be every house or every office. We have controllers which will read humidity and which will automatically set the cut off and cut in limits. So, for example, machines in Chennai will stop working the moment humidity comes below 35 because here you have a lot of scope of making water. Machine in Rajasthan, the humidity machines will keep making water till humidity comes below 15%. So those active like cut off and cut in limits are there. Like you can change it more. I'll answer in two parts this. We have not yet gone hyperscale. Like we are still doing, let's say, 50 pieces, 100 pieces a year, right? Like I have done till 150 machines. So the channels which should be there for, let's say, how does Ola is doing distribution or how Ether is doing distribution. There are channels because now their transactions are happening in thousands. We realized one thing right now that we will not be focusing on B2C because B2C you do 50 machines, but that gets you 10% revenue, 70% headache. B2C gets you 95% of revenue, and you do only, let's say, 12, 20 projects. But it becomes easier for hand holding the B2B. So we have three sectors right now: B2B, under which you have institute different category of institutes, and then so you have B2B and you have CSR and then B2C. So we're focusing on the B2B and CSR. B2C, if something comes up, we take it. We're not spending energy on that unless you cannot be selling that model to Aspria Rai or Sir or my home because people want something which goes with their fridge or with their microwave oven or with their bedroom or with their whatever the background is. This doesn't go right now. So there's a more money like design, IoT. So there more needs to be done for scaling it up. Short-term pain is, let's say, there's a customer who has very high potential, right? And he says, "Okay, do this, do that," and just you want to avoid having headaches, hard discussion with him, and say, "Okay, yes, sir, why not? I will change the filters free of cost." But then you're setting up a very big miss. This guy will become unhappy next time the moment you ask him for the money, and the potential that you were seeing, he is the next auto manufacturer. He can give you 20 machine orders. The guy is angry at you because you gave him free services initially. Now you're asking him for 5,000 rupees payment. So that, and then you should clearly put it in the document that this will be free, this will not be free. Yes, we will try to make you happy, but you know something will be at some cost. Remaining everything we can do at free of cost. So I tried not to take like till date when some people calls me for service, I say ki, yes, I will get it done. But my CEO, he will say ki, no, I'm doing first only because Ramesh said it will be free. This is last for you, and he clearly mentioned in the document, and he takes that headache. And once he takes that headache, my life automatically becomes easier because I did not, I don't want to make the customer happy solely because my thinking has been from the no, from the sales perspective. I will keep you happy. I make sure that you keep buying, but the operation has to be handled also carefully. This is one of such things. Funding, we keep on writing to companies. IIT Madras was also instrumental in the funding that we got. So we received initially grants, and like the grants has helped us to build the product. Post that, like it's a mistaken psyche that I had. I kept on putting my personal funds, so the company is survived. Uh, Not a good thing to not account and keep putting your personal funds because then your personal life gets messed up sometime and you can't do better business. Uh, but yes, post COVID, the grants were not much because the money got diverted everything to health and other sectors. So we started sales with whatever we had, and the sales has kept us alive. So now we are focusing more on the sales, less like we are focusing on the raising money also. We do get grant. We keep writing proposals. So yes, please keep writing proposal. That sometime really and comes handy. But customer is the only thing right now which is. Till date, let's say we've done around 5 crore. So that has helped us to keep running. See, I have COO now. Uh, I haven't, like, even at the start of my journey, I haven't been much. I will chase CEO and CTO, and sounds fancy. Gives you different job role entirely. Somebody will be doing all the time shirt, coat, and flying, and one guy will be all the time in factory doing his hand dirty. But I had till the time the logic makes, if your skill set makes sense and the other guy is able to deliver, take that chance. uh, I'm right now have CEO, but like I'm right now, like, since you do not have a lot of team members, you do product, you do sales, you do proposal writing. uh, so when I'm still looking for, like, if there's a good guy who delivers 10 times better than me, why not he becomes the CEO? And I have the technology background. If my skill can build on the tech, then yes. And then if there's a good uh, material scientist who comes along, then why not he be the CTO? So yes, giving up the names and slightly difficult, but bigger than that, it's a giving up the trust. I mean, like, you always think, I will do it better. Let me call this person, and because even if I get an email, somebody saying that your machine is not making 500 liters, it made only 50 liters, and the mail comes second time, and you feel like, I will immediately go now. And you sit in car and, okay, boom, boom, you go to that client office. But then, because you think you are the best person to, because the problem has come second time, you are also irritated, customer is also irritated, and you want to finish it all. I don't want third email at any cost. So the best thing is, you are the best, you go run. But that's the mistake that, the we do. So I don't even, I try to stay away from factory, and I ignore those emails now. uh, and fortunately, after 5 hours, somebody responds to those emails. So, like, let me sit on the back seat, and because unless that system gets developed, you cannot run. The delegation doesn't come easily, and but delegation is usually very, very important uh, to, run a organization. And we don't usually delegate, like, we are the best. So let's say somewhere here I'm, or the center of here, I'm in Indore. I'm extracting 1 lakh liters of air. The dry air will mix up. It will stay in the ambient, but it will keep getting diluted. The mixing will keep happening. But then this air will go to this ocean, the Bay of Bengal, where it will get enriched, and the same air molecule will again go to Thailand, Vietnam. So it makes a round across the planet in around 6 days of time. So these are called atmospheric rivers, and the entire circle happens in around 6 days. So it comes back, like, those specific air molecule. If I were to talk, they comes back in around 6 days of time if they had the temperature. The hot air has high water content in it. And the colder air doesn't have water content. So the best indication thing is that once like, you see fog every day in the morning time or winter time in all the rice fields, because in the daytime temperature will be around 27. The water is not visible, it's there. But the moment temperature gets colder, water starts oozing out from the air. It starts forming the droplets, and hence in the winter time our skin gets dry. So colder air has less water in it. Hot air has very, like, it has capacity to hold more water. So the southern belt, we have high humidity content. So if the air is very high temperature, it's again good. Uh, so we want high temperature, we want high humidity both. Like, machines are useless in Ladakh. The current, the tech of it, like, I hope, it becomes better. Uh, but they are very good in the coastal climates and the southern part in general, or let's say the Gulf, coastal areas of Gulf cities. salts gets evaporated. So let's say H2O will disappear. It's not visible. But salt usually they have a aerosol. It's not NaCl or calcium sulfate or calcium chloride. These are aerosols, and the weight of this aerosol is usually higher than the water molecule. So they do not really travel very long. So 90% of aerosols or the salt content will fall in the first 100 meters itself. And as you go away with the 5%, 2%, the salt will keep coming, but it doesn't come too much. For example, so if you have Navy office on the coast, they have to mandatorily change their computers also every 2 years on the desktop. But HCL, which is around, let's say HCL in Siri, they have around 3 kilometers. They do not change their computers. So the salt is main problem on the coast. Like even just not really related. A rich person staying on the coast, and we think that yeah, sorry, 10, 50 crores of property, 30 crores of interior, but they have to spend very high on even maintaining their car, because if they park their car on their beach house, the car or the Mercedes will get rusted. So there's a dedicated vacuum sort of car parking that they make. I'm telling this about a very big actor in Chennai, because we're doing a project for that. So even the parking has to be designed in such a way that their Rolls Royce doesn't get corroded. It happens only on that first 100 meters. There only the water content will do the corrosion. The salt is very sort of a catalyzing element for the corrosion, but otherwise it's just you have iron willing to interact, give some electron, take some electron, water content came and it starts. And if its salt is there, then it's okay, so get started. The salt will push that. So there is corrosion on the coast of near a river also, but that's much lesser. Like it's not very high. I hope I balance. Right now there's not high profit, but yes, you enjoy when you see such videos. Uh, just on the go. But yes, you like I do keep some sense key. Uh, like I'm not sure how this is impacting my business right now or will impact that. You do not compromise on the product quality. Uh, that may take some bit of your EBITDA will not come well, or that profit and line profit will not be good. But eventually you're building the you're playing a longer game where the customer will come back to you after 5 years. He will not go the other location. uh, we just focus on the product quality. Social values coming out of it or financial values, that's the secondary outcome. We're not focusing on that. So in that, our IP was to do the drum was there. Drum is somebody's IP. Like the drum is not ours. Our IP was to make it collapsible. Like you have one single drum, we made it collapsible, and then insert the filtration component, the purification element into it. But like we have not, like I did not pursue it longer because I started on the Wisel. So we have not taken it to, let's say, the CSR of Distillery or other agencies. Like yes, somebody will give you uh, very stupid term sheet. I'm saying stupid because I have seen such term sheet, and that's the only word. Uh, and but then you just need one yes, right? PhD, you need one person to say yes. For internship, you need one person. Same is I'm following the same principle. You need one investor out of hundreds who says ki yes. Uh, you build on the quality, and who also believes on the quality. It's B2B. Uh, right now, costing has been like I think very simple. BOM plus your factory overheads plus 20-30% margin, and then you also look at what type of value add you are doing. So I usually keep the pricing on the higher side. We use it for negotiation, and you keep continuously doing the competition survey. Like let's say 4 companies in India. So you keep doing that, and MRP is only what you can fix, but the real deal happens during negotiation only. So uh, we try to communicate on the product quality. There will be customers who will always say, "Ki, we want L1. You give in 7 lakh, I will take yours. He gives me 7 lakh." So sometimes we like step out as in we stay where we want to stay, and the order does go to other person. Uh, so like our pricing has been on the product quality and like what it can really cater. Now we are giving it to B2Bs. CSR is also there, but we are not focusing primarily. Our main customer set is B2B. For example, all the automotive companies today wants to do sustainability in their scope one and then the scope two and everything. They also want their supplies to be sustainable. So we approach, for example, the JCBL, the company which makes heavy duty vehicles, or Daimler or Toyota, and then so we have these 5-10 big names, but on the back end of them you have around 1,000 suppliers, and those suppliers have mandate, I mean, like to have their operation with sustainability. So we approach their suppliers also, somebody who is supplying, let's say, the fluid tube or the chassis or the glass. So we focus on, let's say, uh, listed companies who has mandate of doing ESG, are living in the coastal areas. Also, I cannot comment on that because it also how much effort you're putting on that particular segment. But I think the businesses will, if I do complete, uh, let's say, all the automotive sector of India, it's a big business.